So experiment number 3 is related to we are going for reading and writing data in a complex number. We know that whenever we are going for complex number, it contains a real part and imaginary part. For example, 3 plus 4i. So here 3 is the real part and 4 multiplied by I. So that I indicate it is the imaginary part. And here there is a program for us, program in C++ to perform following operations on complex number. And these operations are like addition, subtraction, multiplication, division, as well as we have to find out the complex conjugate of given complex number. So this program is for complex number, and it's with different operations. And here we have to go for designing the class for complex number. Means we have to define a class here, and we have to perform operation using that class. And the objective of this assignment or experiment is to be learn concept of class and object. We know that a class is a something that should be useful for combining variable of different data types, like a structure in C language. So it is similar to the class in C++. So there is only one difference between class and structure. So the difference is, in case of structure, you cannot declare a function inside a structure, but you can declare a function inside a class, and these functions are called as member functions. So this is the aim of this experiment. Means here you have to go for a C++ program with complex number and different operations. So here we have to go for this particular program. Here first we will include iostream.h. In case of C language, we are using stdio.h, but in case of this particular C++, we have to use iostream, not iostream.h. It is only iostream. Whenever you are writing like this iostream.h, then it shows an error. So you have to write like this hash include iostream, and this is a header file which is useful for definition of functions like cin and cout. Cin is an input function in case of C++, and cout is a output function. And similarly, there is another header file we have to require, as we have to perform different operations on complex number like addition, subtraction, multiplication, division. So we required this cmath.h. We are writing hash include cmath here, and that is required for some mathematical functions needed to be used in this program. And after that, every C program contains this particular line called as using namespace std. So here in C++, we are writing this particular line because we have to define the scope of the cin and cout, and that definition of scope is using namespace. So you have to write like this, using namespace, and std means standard. And after that, we have to go for complex number, and we have to define a class for that. So the keyword for defining a class is again class. Anyone who can tell me what is keyword for defining structure? What is keyword used for defining structure? Anyone unmute yourself and tell me what is the keyword useful in defining structure?
Struct.
Yes, this answer is correct. Struct is a keyword that is useful for defining a structure. So similarly, whenever we want to go for defining a class, the particular keyword is class. And every time keyword is shown in bold letters here, like int, integer is a keyword, then public is a keyword, void is a keyword. So all these keywords are shown in bold letters. And after that class keyword, the name of class is complex here. And under that class, we are going for two variables. One is real and another one is img. Real for real part of complex number, and img for imaginary part of that complex number. So here we can say that it stores the complex or imaginary part of that complex number. And then there is a access specifier for a class. This is again a new thing in class which is not present in structure. So you can go for three types of access specifier. There is public, private, and protected. So according to the access, you can go for public, private, and protected. So meaning of public means something declared inside the public that should be useful for that program or for that class, as well as it can be useful for other classes also. and the meaning of private is that is restricted to that class only, and whenever we are going for protected, so it should be useful for that class and subclass also. And so under this public access specifier, we are going for declaring some functions. They are called as the member functions. And first we will go for read function. Read is useful for taking complex number as an input. Then display is a function that is useful for displaying the complex number. And return type of both this read and display is void. Anyone you can tell me what is meaning of void? What is meaning of void? Anyone unmute yourself and tell me what is meaning of void?
Nothing.
Okay, so this answer is correct. Meaning of void is nothing, means this read and display function doesn't return anything. So there is no need for return zero statement whenever we are going for definition of this read and display function. If the return type is other than void, for example, for this addition function, subtraction function, multiplication function, and division function, the return type is not void, it is complex. So everyone carefully observe here. Complex is a name of class. So this indicates these functions, addition, subtraction, multiplication, and division, they returns a variable which is of class type or complex type. And all particular functions, addition, subtraction, multiplication, and division, they are having one argument that is a class type variable called as a C1. So here you can declare a variable of class type like complex C1. And whenever we are going for variable of class type, it is called as an object. So here we are creating object like C1, and that is provided to addition, then subtraction, multiplication, division. And finally, we want to go for this complex conjugate also. So there is a function for complex conjugate also. And return type of that conjugate function is void, means it doesn't return anything. And there is no argument required for this conjugate function. And before this member function, something is declared here, and this is called as a constructor. So everyone carefully listen here. A constructor is useful for initializing the object created. We are creating object by using syntax like name of class, then name of object, and semicolon, like complex C1. Complex is a name of class and C1 is the name of object. But that object is needed to be initialized. For example, here we are going for these two variables, real and imaginary, but we doesn't initialize here. So we want to write like this, real and imaginary having initial value as a 0. So whenever we want to go for declaring a variable inside a class and we want to initialize them, then a constructor is used. So constructor is useful for initializing the variables which are declared inside a class. And the name of constructor is again same as the name of class. Name of class is complex here. So the name of constructor is again complex here. And we can say that it complex or constructor is a member function because it is declared inside this particular class. So once again, I am telling here, we are declared a class having name as a complex. Then we go for declaring two variable, real and imaginary. And there are different functions, function for reading, displaying complex number, then function for addition, subtraction, division, and multiplication, as well as we have to find out the complex conjugate of a given complex number. And here we have to go for closing curly bracket and semicolon. So that indicates class is ending. So in this way, you can create a class having name as a complex one. Now, all these functions are declared inside a class, but we have to write a definition of all these functions. So first we will start with the definition of read. And we know that this read function is declared inside a class. So you cannot directly write the definition of read function. So for that purpose, you have to use this 2 times colon. Anyone you can tell me what is this 2 times colon? What it is called? Carefully observe here, 2 times colon. It is the operator, and what it is called?
Scope resolution.
Okay, so this is a scope resolution operator. We know that this read function is declared inside a class. So that is limited to that class also, or the scope of that read function is limited to that class. You have to resolve that scope of that read function. So here you have to write like this, name of the class and then scope resolution operator, and then name of function. And before this name of class, return type of that read function is void. It is as it is. And here reading means we have to take input from user and store in the memory. So input means here it is a complex number. So we want to go for taking real part first and then imaginary part. And by using the C in real and C in imaginary, you can store this real and imaginary part into the memory. In case of C language, we are using scanf as a C in, and we are using printf as a C out. But in C++, we are using C out and C in. These are the input output functions in case of this C++. Similarly, we have to go for this display definition, and displaying means we want to go for displaying the complex number. So here we are using C out or printf in C++. In C++, we are using C out, and here we want to display like real part plus imaginary part. And whenever we want to go for complex number, then real imaginary part is multiplied with I. So we are writing like this, imaginary multiplied by I. So you are getting an output like this, 3 plus 4i. So here 3 indicate real part and 4 indicate imaginary part, and multiplication with I. So this is what we can say that reading and display function definition. Now we have to go for again definition of addition function. And again, addition is declared inside a class. So we require this class name and scope resolution operator for accessing that addition function. And return type of this addition function is not void. Instead of that, it is complex here. So this indicates this addition function returns a value which is of class type. We know that complex is the name of class here. So this particular definition end with the return statement. Here return type is other than void. So here this we are ending this definition of function. So it is equal to return in bracket add. So here we are going for declaring an object add, which is of class type or complex type. And if you want to go for accessing these real and imaginary, these two variables are declared inside a class. And if you want to go for accessing using this object add, then you have to use dot operator. So you are writing like add dot real and add dot imaginary. And here we are going for definition of addition function. So how to go for addition of a complex number? So see here, we know that whenever we are going for complex number, so it is in terms of a plus bi, means it contains real part and imaginary part. And whenever we are going for addition of this two complex numbers, suppose first complex number is a plus bi and second complex number is c plus di, then what we are doing, we are going for addition of real part and addition of imaginary part separately. Means here in this first complex number, a is a real part, and here in second complex number, c is the real part. So we are writing like output like a plus c, and here in first complex number, the imaginary part is b, and here in second it is equal to d. So we are making I as a common, and we are writing like this b plus d. So you are getting an output like a plus c plus b plus d multiplication by I. For example, first complex number is 4 plus 8i or I8, and second complex number is 5 plus 7i. Then what we are doing, we have to go for addition. So we will add real part like 4 plus 5, which is equal to 9, and 8 plus 7, which is equal to 5. That is addition of imaginary part. So all of you are getting how to go for addition of two complex number? All of you are getting, yes or no? How to go for addition of two complex number? All of you are getting, yes or no? Everyone carefully listen here. What we are doing, we are addition of real part is done and addition of imaginary part is done. So same thing you have to write in programming language. So here we are going for some variable like a equal to real and b equal to img, then c equal to c1 dot real and d equal to c1 dot imaginary. So here some dot real, or in case of this program, we had declared variable as a double d, not a sum here. So you can write like this, add dot real equal to real part of first complex number plus real part of this second complex number. Similarly, add dot imaginary, which is equal to imaginary part of first complex number plus imaginary part of second complex number. So in this way, you have to write like this. It is real plus c1 dot real, then img plus c1 dot img. Means here we are going for addition of this real part separately and imaginary part separately. And now I have to go for writing a message like addition is, and then I am going for display, calling display function because I want to display the output. And here the return type is complex. So here we have to return that addition. So variable for that is a double d. So we are writing like this, return in bracket a double d. Similarly, we can go for subtraction, and again subtraction is similar as we go for addition. Means in case of addition, we are going for addition of real part and addition of imaginary part separately. Same thing we have to do in case of this subtraction. There is a subtraction of real part separately, which is indicated by difference dot real, and the subtraction of imaginary part is indicated by difference dot imaginary. So we are going for definition like real minus c1 dot real and imaginary minus c1 dot imaginary, and we are printing output like this subtraction is, and then calling this display function. And here type is other than void, which is a complex. So we will go for returning this object sub. Now we will go for multiplication. We know that in case of addition and subtraction, what we are doing the real part addition separately and imaginary part uh, subtraction or addition separately. But in case of division, can we do like this? Means multiplication, sorry, in case of multiplication, can we do like this, multiplication of real part and multiplication of imaginary part? Yes or no? We are going for multiplication here. So anyone you can tell me, can we do like this multiplication of real part and multiplication of imaginary part as we had did in addition and subtraction? Yes or no? So answer is we can't do like that. Means we here we what we have to use, we have to go for certain functions like we suppose first complex number is a plus bi and second complex number is c plus di, and we have to go for multiplication of these two. Means what we are doing, we have to multiply one by one or element wise, like a multiplied by c, so it is ac, then a multiplied by di, so it is adi, then b multiplied by c, so it is BIC or BCI, and finally there is a B multiplied by D and I multiplied by I, so it is equal to I square. And value of I square equal to -1, so we know that this plus sign become minus. And now we have to go for this particular equating the items and other than items. So we are writing like this, AC minus BD and then AD plus BC multiplied by I. So in this way, you can go for multiplication of two complex number. Once again, I am telling we are going for element wise multiplication here. Means a multiplied by c, so it is ac, then a multiplied by di, adi, then we are going for this b multiplied by c, bci, and finally b d, and I multiplied by I, so that is I square, and value of I square equal to -1, so this plus sign become -1. And now we are going for grouping the terms of I and non-I terms. So we are writing like this, AC minus BD plus AD plus BC multiplied by I. So whenever we are going for this writing in programming language, we have to write like this, AC minus BD plus AD plus BC multiplied by I. And we know that here A equal to real and B equal to imaginary, then C equal to C1 dot real and D equal to C1 dot imaginary. So suppose I want to write like this AC. So AC means real multiplied by C1 dot real. So it is real multiplied by C1 dot real minus BD. So BD means imaginary multiplied by C1 dot imaginary. Imaginary multiplied by C1 dot imaginary. And this indicates the real part because there is no multiplication with I is present over here. And similarly, this is an imaginary part. So AD means real multiplied by this particular C1 dot real. So here we are going for, sorry, it is not AD plus BCI. Okay, so here we are going for AD means real multiplied by C1 dot real, then plus BC means equal to imaginary multiplied by C1 dot imaginary. For multiplication, we are writing like this, multiplication of imaginary, real multiplied by C1 dot imaginary. Here it is real means A and C1 dot real equal to C. So here you have to write like this. Means for real part we are writing like this, and for imaginary part we have to write like this, real multiplied by C1 dot imaginary. So real is A multiplied by C1 dot imaginary. So it is A multiplied by D and plus C1 dot real. C1 dot real means it is equal to C, and then imaginary means it is equal to B. So it is C1 dot real multiplied by imaginary. Here it should be changing like real multiplied by C1 dot imaginary. Here it is instead of IMG, it is real multiplied by C1 dot IMG, and then here it is equal to C1 dot real multiplied by IMG. Now it is correct. So it is real multiplied by C1 dot IMG. Real means A and C1 dot IMG means D. AD plus BC. So in this way, you can go for multiplication. And again, we have to display the multiplication. We have to call display function and returns this object MUL, which is created for storing multiplication output. And similarly, we have to go for division. But whenever we are going for division of two complex number, then there is a process is like this. Means suppose we want to go for division of two complex number. Here two complex number are A plus BI and C plus DI. So for this division, what we are doing, we are multiplying this denominator and numerator by complex conjugate of this denominator. Denominator here will contain C plus DI. So the complex conjugate of that is C minus DI. So you have to multiply on top and bottom of this numerator and denominator by using complex conjugate of C plus DI. So it is A plus BI multiplied by C minus DI, then C plus DI multiplied by C minus DI. So this is first step. Now second step is we will go for a multiplication. So it is AC minus BDI plus BIC minus BDI square. And we are equating these items and non-items. So you are getting output like this: AC plus BD plus I in bracket BC minus AD. And now here in denominator, whenever you can multiply this C plus DI multiplied by C minus DI, then you are getting an output like C square plus D square. And here I am writing for this particular item separately and for non-item separately. So you are having an output like this: AC plus BD divided by C square plus D square, and item is BC minus AD divided by C square plus D square. So for example, here these are two complex number. So what we will do, we will multiply complex conjugate of denominator means 4 plus minus 5y, and complex conjugate of that is 4 plus 5y. So you have to multiply in the numerator as well as denominator also. And now we will go for element wise multiplication. Here this plus 20i and minus 20i get cancelled, and value of I square equal to minus 1. So you are getting final output like this: minus 7 plus 22i divided by 41 whenever we are going for this division between two complex number. So process of division is, first thing is step number 1 is we have to multiply this numerator and denominator by using complex conjugate of denominator, and then you will separate out the terms of I and non-item, and then you can go for like this. So here we have to write down all these equations in terms of programming language. We know that A is equal to real and B equal to imaginary, then C equal to C1 dot real and D equal to C1 dot imaginary. So we have to write like this: AC plus BD divided by C square plus D square. So AC plus BD, A means real and C means C1 dot real. So it is real multiplied by C1 dot real. So it is equal to AC plus BD. B means imaginary and D means C1 dot imaginary. Means it is imaginary multiplied by C1 dot imaginary. And now we want the C square plus D square. So C is C1 dot real. So you can write like this: C1 dot real multiplied by C1 dot real. So it is equal to C square. And finally D equal to C1 dot imaginary. So you have to write like this: C1 dot imaginary multiplied by C1 dot imaginary, means it is D square. And so this is a particular term called as real, means this doesn't contain I. And after that, there is a BC minus AD divided by C square plus D square. So BC means here imaginary multiplied by C1 dot real minus AD. AD means again here real multiplied by C1 dot imaginary and divided by C square plus D square. So it is C1 dot real multiplied by C1 dot real plus C1 dot imaginary multiplied by C1 dot imaginary. So in this way, you can go for complex division. And here we know that you can write like the c square and d square in this way also, means here you are going for POW function. So POW means it indicate the power, and it is an inbuilt function, so that we have include here cmath.h. So that is for this POW function, and you can write like this p1 in bracket c1 dot real comma 2, means it is equivalent to c square and d square. Or you can write like this, it is c1 dot real multiplied by c1 dot real, c1 dot imaginary multiplied by c1 dot imaginary, or you can write in this way. Both are correct. And now we want to go for displaying the division. And finally, we are having a definition of this conjugate function. So conjugate means we have to find out the complex conjugate. So real part is again equal to real part in case of conjugate, but the imaginary part is minus imaginary, means there is a sign change. Means suppose we are going for 4 plus 5i as a complex number, then complex conjugate of that is 4. If there is 4 plus 5i, then it is 4 minus 5i, means there is imaginary part sign is changing. So you have to write like this, c1 dot imaginary equal to minus img, and it does not return anything. So here there is no return zero statement, because here return type is void. And now after writing definition of all these functions, we have to go for main function. And inside main function, we are creating object a and b. First we have to read the a and b, and now I have to go for calling this addition, subtraction, multiplication, division, as well as conjugate function for a and b. And now return type is integer here. In case of C++, the main function has a return type as integer. So this program end with return zero statement. So in this way, we are going for this program. We have to compile this program by using this option like execute, and under that compile. And after there are zero errors and zero warnings, we are going for running this program. So after running this program, a separate window is open, and here asking like enter the real and imaginary part of complex number. So we have to suppose first number is 4 plus 5i. So the real part is 4, and second number imaginary part is 5. Then again it is asking for second number. Suppose that number is 10 plus 12i. So it is real part is 10, and then imaginary part is equal to 12. And here we are going for addition, subtraction, multiplication, as well as division also. So addition is equal to 4 plus 10, so which is equal to 14. Then 5 plus 12, it is equal to 17. There is a real part addition and separate imaginary part addition should be done here. Similarly, for subtraction, it is 4 minus 10. So it is minus 6, and 5 minus 12. Again, it is minus 7. For multiplication, that different logic is used, and you are getting output like minus 20 plus 98i. And here division is not possible using these numbers. So here output is 0 plus 0i. And for complex conjugate, it is equal to 4 minus 5i. Means real number is 4 plus 5i. Then complex conjugate is 4 minus 5i. And for 10 plus 12i, it is 10 minus 12i. I will go in for some once again running for this division also, because the previous complex number doesn't having an output for division. So I am changing numbers here, like first number is 1, then 2. So it is 1 plus 2i, and it is 3 and 4. Now again I am not getting an output, so I have to change again complex number. For example, suppose these are values. Here we are taking output like 2 plus 3i and 4 minus 5i. So real part is 2, and then imaginary part is 3. And here again 4 minus 5i. So real part is 4 and imaginary part is minus 5. Now we are having numbers like 2 plus 3i and 4 minus 5i. And now we are getting an output of division. So which is again 0 here. And we are getting all other outputs. Once again, I am running here. Suppose it is 4 and 5 and 1 and 3. Then you are getting an output here like 1 plus means real part is present. So here output is 0 means it is 0 point something. So that is equate to 0, and it is shows an output like 0 plus 0 in case of division. So in this way, you can go for this program. If you have any doubt in this, you can tell me.